Hello dear students, in this video we are going to talk about piecewise functions. A piecewise function is a function that is a combination of one or more functions. For example, here you go to the example 2. For example, we have a piecewise function like this. This is a piecewise function. We have more than one function. We call it a piecewise function. The example 2 talked about, we skipped the example 1. So we move to example 2. We have evaluating a piecewise function. These two examples are solved, so we are going to move to the check it out examples. It said evaluate each piecewise function for x equals to 3 and x equals to -1. So we are going to evaluate each of them by having these two values of x. First one, x equals to 3. What is the place of 3 in these three domains? We have to find this 3 in these three domains. Let's write branch A and B here. First we are going to plug x equals to 3 and the second one x equals to -1. We plug 3 first. We are going to look these three intervals. Is 3, we try for the first one, is 3 less than -3? No, 3 is greater than a negative numbers. Is 3 between -3 or 6? Yes, 3 is located between -3 and 6. So 15 is our solution. It will be f3 equals to 15. That's it. What about x equals to -1? What about this one? Again, we are going to look at these three domains. -1 is less than -3. No, -1 is greater than. Is -1 between -3 and 6? Yes, because we have -3, -2, -1 is between -3. Again, f of -1 equals to 15. That's it. If you solve the branch B, let me write it. Is 3 is less than, we are going to look at the domains here. Is 3 less than 0? No, 3 is greater than, so it's not right for the first one. Is 3 greater than or equals with 0? Yes. So that one will be our solution. So we have f of 3 equals to 5x minus 2. When we plug 3 here, it will be 5, 3 minus 2. So 5 multiplied by 3 is 15 minus 2 equals to 13. That's it. The difference between the previous example we don't have x, so we put it as itself, but in here we have x, so we have to find the function, we have to evaluate it. Because we have the value of x, we put it here, so our final solution will be 13. So fx equals to 13. What about -1? That one for x equals to 3. What about if we have x equals to -1? How can we put it? So -1 is less than 0. So the first function will be our solution. F of -1 equals to 3x to the power 2 plus 1. When we put -1 here, it will be 3 multiplied by -1 to the power 2 plus 1. So any number to the power of 2 or even power, it will be a positive. So 3 multiplied by 1, it will be 3. And we have plus 1 here. 3 plus 1 equals to 4. This is how we evaluate a piecewise function. Let's solve some more examples in the book, exercises. We move to the exercises. Look at here. It said evaluate x equals to -6 and x equals to 3. We have to put it here. So when we put -6 in these domains, -6 is less than or equals to -5. So that one is true for the first one, for x equals to -6. So it means we have f of -6 equals to -8. We don't need to evaluate and put x because we have just a number. We don't have x to put it. What about x equals to 3? F of 3. We have to find our function. Which function is our solution? Is 3 less than -5? No. So the first one is not true for x equals to 3. Is 3 between -5 to 6? Yes, it is between here. So equals to 0. So our function is 0. So f3 equals to 0. But for here, it's different. For example, 5. Because we have x. If we have x, it will be different. We have x equals to -6. First, we have to plug this one. Is -6 less than 2? Yes. So we can put -6 in the second one. So it will be g -6 equals to 5x minus 9. So we can put -6 here. It will be 5 multiplied by -6 minus 9. 5 multiplied by -6, it will be -13. -30 minus 9, so equals to -39. What about the second one, which is x equals to 3? Is 3 less than 2? No, so it's not true for the first one. Is 3 greater than or equals to 2? Yes, so 3, we can put 3 here. It will be g3 equals to 4 minus x squared. We can put 3 here. Immediately we can say 4 minus, this minus should be here, and 3 to the power 2 is 9. 4 minus 9, it will be -5. That's it. This is how we found, or this is how we evaluate a piecewise function. The next example that we have is example 3. Example 3 is about graph. How can we graph a piecewise function? How can we graph a piecewise function? Here we have two types of graph. Here we have two branches, branch A and branch B. Branch A, we don't have any x here, it's just a number. Branch B, we have x here. We have x. But in branch A, we don't have x, it's just a number. How can we graph them? To graph the first example, if we have just a number, to graph it, we need just points. So our point of x is 2 and y is -4, because that one also is y, this one. So our x is 2 again, and our y is 4. We have to graph them. So we have 2 with -4. 2 with -4. So this will be our point. Do we fill out the circle or not? We are not going to fill the circle because we don't have equal sign here, but for the second one we are going to fill it. But for the first one we are not going to fill out. Our graph is x less than a number. If x less than a number, it means it goes for negative parts, and our graph will be a horizontal because we have just a number. If it is a number, our graph will be a horizontal. let me give you this hint. If it is 4 or just a number, the graph will be horizontal line. If it is x, our graph will be like this. Our graph will be like this. If it is just x, our graph will be like this. If we have x to the power 2, our graph will be like this. So because we have just a number, so our graph will be a horizontal line. And for the second point, we have 2 with 4. 2 with 4. So do we fill the circle? Yes, because we have equal sign. And x is greater than a number. It means it goes for positive parts. So it goes for positive parts. This is how we graph it. Now we have to find the domain and range. For a domain, we are going to look at x-axis. From which point of x we have graph? So we see that from negative infinity until 2, according to x, we have graph. But it is break, we have a break. But above, from point 2 with 2 and 4, we have another graph. It goes to positive parts. It means from all points of x we have graph. It means our domain is the set of real numbers. It means it is R. What about the range? For range, we are going to look at y-axis. From negative infinity, when we come, we don't have any graph until negative 4. So negative 4 is, we have it, which is a domain. But from negative 4 to 4, we don't have a graph. Until 4, we don't have a graph. Just in 4, we have a graph. So negative 4 and 4, we have a graph. But from 5 or 4 above to positive infinity, we don't have any graph. So negative 4 and 4 is our range, because just in 2 points we have a graph. And what about the continuity? Look at this one. Be careful what I say. If we have any break, it is discontinuous. Discontinuous. If we don't have a break, they are stick together. If you have the graph together, so it is continuous. But because we have a break here, so we have this whole break, so our graph is discontinuous. This is how we graph and find the domain and range and determine the continuity. Let's solve branch B. For branch B, as you see, we have x. We have x and x squared. So in this case, we have to graph it by table. We have to graph it by a table. If you don't want to do any mistakes, we have some ways, but this is the best way that you will not do mistakes. So we have x and y. For example, we have how many points we can give it to x. We cannot give it randomly. We have to look at this domain. The domain starts from negative 3. So we have negative 3. And x is less than negative 3. It means we have negative 4, we have negative 5, we have negative 6. 4 points is enough. For every example, 4 points enough. If our x is power 1, we can just give 2 points, but you can give also 4. But if it is square power, it's better to give 4 points. And then we are going to put these values of x in here for the first one, because this graph is the first function. The first one, if you plug negative 3 here, 3 multiplied by negative 3 is negative 9 plus 8 will be 1, negative 1. If you put 4, it will be negative 4. If you put negative 5, it will be negative 7. It will be, if we put negative 6, it will be negative 10. And here for the negative 3, we have equal sign. We have equal sign. So we are going to fill the circle out. So put this dot here. It means we are going to fill the circle from this point. This is the first table. For the second table that we can do, we have x and y. We have to put these two domains here. We have to put it here. We have negative 3 here and negative and 1 here. And we can choose two numbers between negative 3 with 1. Let's say we have negative 1 and 0, the easy points. We can take it. So we put these values of x from our y, which is negative 2x. Negative 2 multiplied by negative 3, it will be 6. Negative 2 multiplied by negative 1, it will be 2. Negative 2 multiplied by 0, it will be 0. 1. Negative 2 multiplied by 1, it will be negative 2. This is how we do the second table. The third one, x and y, we have to start from this interval, which is 1. Oh, sorry, I forgot this one. Here we have negative 3 and 1. We don't have equal sign. We are not going to fill these circles out. We are not going to fill this circle. So we are going to just put like a circle. To know when we graph it, we know that we can fill the circle or not. Here we have 1. 1, x is greater than 1. So it means we have 2, 3, 4. We cannot put the points randomly. We have to look at this interval. So we can start from 1 and 2, 3, 4. It's up to you. And then when we put 1, it will be 1 minus 3. It will be negative 2. If you put 2, it will be 4 minus 3, which is 1. 9. If you put 3, it will be 9 minus 3, which is 6. And 12 minus, and if we put 4, it will be 16 minus 6, which is 13. And in here for 1, we are going to fill the circle because we have equal sign. For graphing the first one, we have to just put the points or plug the points here. We have negative 3 with negative 1. Negative 3 with negative 1, which is here. And we are going to fill the circle out. Here we have negative 4 with negative 4. Negative 4 with negative 4. We don't need to make a big circle, just put a point here. We have negative 5 with negative 7. Negative 5 with negative 7. And we have negative 6 with negative 10. Negative 6 with negative, let's say, assume that it is here. We connect these 3 points together, so our graph will be like this. And for the second graph, we have negative 3 with 6. Negative 3 with 6 here. We have an open circle. We are not going to fill it. And we have negative 1 and 2. Negative 1 with 2. Just put a point, small point. And 0 with 0. This is 0 and 0. And 1 with negative 2. 1 with negative 2. We have an open circle. And we are going to connect these two together. We connect these two together. This is how we connect them. For the third one, for the third graph, we are going to plug the point, which is 1 with negative 2, 1 with negative 2. We fill this circle because this point is a full circle here. We fill it. And we have 2 with 1, 2 with 1. And we have 3 with 6, 3 with 6. And we have 4 with 13. So we can leave this one because we don't, it has much more points here. We can leave it. So just connect them together. Sorry for my handwriting that is like that. So it goes up until positive infinity. Let's find the domain and range. Let's determine them. For example, we have a domain here. For a domain, we are going to look at x-axis. This line, it goes for negative infinity according to x. So from negative infinity that we come, we have a graph until negative 3. From negative 3, we have a break. But here, it is continue. So until 1. So we have another break, but it is continue until positive infinity of x. This line goes like this according to x-axis. It goes to positive infinity. So domain is the set of all real numbers. So this is R. But for the range, look at the range. We are going to look at y-axis. We don't count for x-axis. We just look at y-axis. This graph, it goes for negative infinity of y. So from negative infinity until positive infinity of y, because this line goes for positive infinity, we have graph. So it means also the range is the set of all real numbers, which is R. And because we have a break here, our function is discontinuous. We will graph another one in, for example, 3. To graph this function, because we don't have x, just a number, so we are going to just take points. We have negative 2 for x and 7 for y, and we have negative 2 again for x and negative 2 also for y. So for negative 2 with 7, for the first one, negative 2 with 7, here is 7. So we are not going to fill the circle because we don't have equal sign. And x is less than a number, so it means it goes for negative sides. And then here for the second point, we have negative 2 with 2, negative 2 and 2. We are going to fill the circle, and x is greater than a number and equal. That's why we fill it, and it goes for positive sides. We have to find the domain. Our domain is R, the set of all real numbers, because here it goes for negative parts of x. For domain, we are going to look at x-axis, and then it is from negative x. It comes from negative x to negative 2 here, and we have a break, but the graph is not finished, and from here the graph starts to positive infinity. It means we have the set of all real numbers for the domain, so it means domain is R. And for range, we are going to look at y-axis. As you see, we have a graph in just 2 and 7. So 2 and 7 is a domain, it's a range. Then for the continuity, we have a break here. So our graph is discontinuous, or our function is discontinuous. Number 7, we have in question number 7. We have x, so we have to graph it by a table. We have x and y. Here we have x and y. We are not going to choose the points randomly. We are going to look the interval or the domain, which starts from 4, and x is less than 4. It means we have 4 and 3 and 2 and 1. When we put 4 here, negative 2 multiplied by 4 is negative 8, plus 4 will be 0. That's it. And we are going to fill this point because we have equal sign here. We have equal sign here. We have x and y. Here we start from 4. We start from 4 and x is greater than 4. It means we have 5 which is greater than 4 and 6 and 7. We take 4 points for both of them. And when we put 4 here, it will be 1 over 2 multiplied by 4, which is equals to 2, or 4 divided by 2 is 2. And if you put 5, it will be 2.5. If we put 6, it will be 3. If we put 7, it will be 3.5. And now here we are not going to fill this circle. Why? Because we don't have equal sign. Let's graph the first table. We have 4 and 0. 4 and 0. So the point will be here and we are going to fill out. And we have 3 with 2. 3 with 2. We have just a point. And 2 with 4. 2 with 4. And we have 1 with 6. 1 with 6. Let's graph it. For the second one, we have 4 with 2. 4 with 2, but we are not going to fill it out. And we have 5 with 2.5. 5 with 2.5. So the next point is in here. And we have 6 with 3. 6 with 3. And we have 7 with 3.5. Here we have 7 and 3.5 is nearly here. Now connect them together. It goes like that. It goes for positive infinities. Okay. For a domain, we are going to look at x-axis. As you see, the blue graph, from negative, it goes for negative infinity, and that one goes for positive infinity. It means we have a graph from every point of x. So the domain is the set of all real numbers, or we can just write R. And range, as you see, from negative infinity until 0 of y, we don't have any graph. From 0 starts to positive infinity. So it means from 0 it starts and 0 is include to positive infinity. And our function is discontinuous because we have a small break here. That's it. This is how we graph the function. For example 21, we have fx equals to absolute value of x. To write this one as a piecewise function, first write this. Fx equals to, and we have two functions. Why? Because if we put positive within absolute value, we will get positive result. And if we put negative, we will get negative result. How? If you put 4 equals to 4. If we put negative 4, again we will get 4. So it means we have two ways, we have two fractions, two functions. Okay. And then the first one we will write like this. This is always is like that. It will be if x is greater than and if x is less than. How can we find the functions and the domains here? First, we are going to write the function as itself without absolute value. We are going to write as itself. for the second function, we are going to write the inverse of inside of the absolute value, which is negative x. And then how can we find the domain here, these two domains here? We are going to look at the absolute value again. We equalize inside the absolute value by 0. X equals to 0. So our interval is 0. That's it. Maybe it doesn't make any sense for you. Let's solve 22. It will be clear. For every questions, we are going to deal with the absolute value. We are not going to deal with the others. Most of the times we are going to deal with the absolute value. First, write the piecewise function. This is always like that. And how can you find these two functions? We are going to write the inside of absolute value as itself, and for the second one we are going to write the inverse of it. So we have x minus 4 as itself, and the inverse of inside is negative x and positive 4. Negative x plus 4. And then how can we find these two domains here? We are going to look at the inside of the bracket. We equalize it with 0. So it will be x minus 4 equals to 0. And we move this negative 4 to the other side. It will be x equals to 4. So this is our domain. So we can write 4 here and 4 here. That's it. Let's solve 23. Just write the form of piecewise function. We have h x equals. How can we write this one? We said that we are going to look at the inside of the absolute value. First, we rewrite as itself, and it is inverse. So the first one will be 2x minus 4, and the second one it will be negative 2x minus 4. We are not going to change this minus because it's outside the absolute value. Maybe you say, teacher, this one is also outside the absolute value. How we change it to the negative? Okay, let me give you a clarification here. For example, if you change the inside of bracket for the inverse, it will be 2 negative x in a bracket minus 4. These two, we have a multiplication here, so we multiply them. It will be negative 2x minus 4. So we didn't change this one. But when we multiply these two together, it will be negative 2x. That's why we changed to negative 2. And then how can we find this interval? We are going to just look at the absolute value. X equals to 0. So our interval will be 0. We are not going to put negative 4 here because we are going to just look at the absolute value. Thank you for watching.